Okay. So today's topic is about scale engineering, architecting for peak performance on AWS. I'm Gaurav Purandare, currently leading cloud operations at Contentstack. Let's start with who we are. This is our journey. So back in 2018, Contentstack was established as content experience platform, and we never looked back. This is the journey which shows how we evolved as a company from a product company to a platform. So we started as headless CMS pioneers in 2018, and right now we are targeting to become next generation composable digital experience platform. We are very well recognized by industry analysts. In fact, the recent Forrester DXP category, we are rated 5 out of 5 for our architecture and vision. So, as I mentioned, Contentstack is a digital experience platform. We help our customers by reducing their content development time by 80%, 90% reduction in time to publish, and phenomenal, almost 300% return on investment, right? We have hundreds of customers. Few are listed over here. You can see if you are using Airbnb, that content is being served by Contentstack. We are helping Airbnb for that. How cool is that, right? Talking about scale, at present, we are serving 2 billion API calls. 2 billion. Yes, you heard it right. That's 9 zeros on top of 2. All this while maintaining single-digit SLOs, single-digit millisecond latencies of SLOs, and all of our releases are planned with zero downtime. Talking about scale, we have few things to consider. So we have to maintain the high release velocity. We need to preserve the quality, and all this while keeping the cost low. With this, we were able to achieve 800 releases last year. That's typically 3 releases per day. So today, as I mentioned, we are going to talk about all the insights we gathered over the last few years. Let's dive deeper into it. We are talking about design patterns for peak performance. So, one of the most challenging things we observed at Contentstack is, no matter how much powerful server you have, if you have the latencies while serving the traffic over the internet to the end users, you have a very sad end user, right? So we were really scratching our head over this problem. How do we beat this problem, right? So how do we beat that? And we used AWS Global Accelerator for that. With AWS Global Accelerator, your traffic is served over well-monitored, congestion-free, redundant AWS network that gives around 35 to 40% faster performance compared to the traffic if it was served over the internet. You get one additional advantage on top of it. If you have a customers that they have a requirement to whitelist the IPs, then you get static IP addresses with this solution, right? This was all about over the internet traffic, but we did not want to stop on that one. The next problem we wanted to address was, how do we improve the speed within the AWS network, right? When we are interacting with different AWS services through our application, how do we improve on that speed, right? So we use VPC endpoints for that. For the services like S3, OpenSearch, where your content is hosted. So at Contentstack, when we are accessing the assets that are stored in S3, we use S3 VPC endpoint. And with that, we are able to access the content faster and in secure manner within the AWS network. On top of it, you have a very good advantage that you avoid the NAT gateway data transfer cost, which will be there if you were accessing these services without VPC endpoint. Awesome. Now, we are a content company, and we basically serve the content to our end users with lowest possible latencies. A lot of our application assets are stored in S3, and we are talking about millions of S3 objects. Now, the thing is, how do we improve our performance of accessing the multiple S3 objects concurrently? We faced this issue, and we came up with some strategy on optimizing the S3 access performance and achieving high throughput. So first, you can start naming your objects, S3 objects, with prefixes, as simple as A123. The next prefix could be A456, right? And there is no limit how many prefixes you can have in the S3 bucket. With that, you are able to concurrently achieve the speed per prefix that is listed over here, and you can achieve high throughput using this. There is just one trade-off you need to remember. This solution scales automatically. However, the scaling is gradual. So if you are expecting any huge spike in S3 access, then you should be having intermediate caching mechanism to support your traffic. When we are talking about scaling, we are talking about auto-scaling, but obvious, right? We got that covered. Well, that's what we thought initially, right? But originally, we had the default CPU and memory-based auto-scaling covered. Over the years, as we faced the different use cases, we realized, based on the workload, your auto-scaling requirement need to change, right? If you are expecting a lot of incoming requests, then naturally your workload should be scaling based on the number of requests. If you are expecting your workload has some background job processing to be done, then your workload should be scaling based on the number of messages that are ingested in the queue. And there could be some additional scaling parameters that we will continue to add throughout our next journey, right? The most important thing is to consider that scaling is inherited as your DNA, right? So when scaling becomes your DNA, in everything you do, you think about that, right? And with that, this was an example for horizontal scaling, meaning you are either increasing your EC2 instances or increasing number of pods in the Kubernetes cluster. We did not want to stop over there. We wanted to achieve the vertical scaling for the database systems as well, right? So we are scaling today the database systems based on CPU and memory workload that database systems have. Usually, the scaling is associated with high availability and fault tolerance. So when we are talking about these, at Contentstack, we ensure we are leveraging the fault-tolerant infrastructure that AWS provides, meaning we are making use of multiple availability zones wherever possible, be it load balancers, be it NAT gateways, or any other services. If we have planned the AWS network properly, is it sufficient to achieve the scale? Yes? No? No. Because eventually, when your application is processing the request, you might be receiving I/O throughput issues, right? So for that, you need to ensure that you have optimum storage performance as well. And for that, depending on this workload, you need to select the right type of EBS volumes. So for the general workload, you can go ahead with GP3. If your workload is I/O intensive, you can select to go ahead with IO1 or IO2 block express storages. Now, at Contentstack, our core job is to serve the content to our end users with lowest possible latencies, as I mentioned earlier, right? And we want to focus on our core job. While doing that, we make use of many AWS services that contribute to our target in achieving our target, right? And it makes total sense to leverage those AWS managed services, right? It becomes easier for us because we avoid any operational overhead that might come if we are managing those services ourselves. We get all the best practices integrated out of the box by AWS. There are few service examples we have, like AWS OpenSearch, managed services for Kafka, and AWS Elastic Cache, which is what we are using as of today. Now, we need to understand that security is integral part of any design. And we need to be aware that shared responsibility model AWS follows. So AWS is doing their part by implementing security best practices on all the services that are provided by AWS. And we need to play our part by ensuring that we are securing the in-transit traffic or the data at rest by using customer managed keys, right? So that's a wrap. And I thank you all for today. If there are any questions, please feel free to ask.